going to look at solving linear systems in a problem-solving form. So we have this question here. It says, Charmaine traveled at an average speed of 110 kilometers an hour from Toronto to Sudbury. Okay, and usually when I read a word problem, I'll go through it once, and then the second time through, I'll highlight what's important. Okay, so she then continued to Sault Ste. Marie at an average speed of 95 kilometers an hour. The entire trip without stopping was 6.5 hours. The entire distance traveled was 670 kilometers. Find the distances to each city. Okay, a lot of info, so I want to do this again. Charmaine traveled at an average speed of 110 kilometers from Toronto to Sudbury. Okay. She then continued to Sault Ste. Marie at an average speed of 95 kilometers an hour. Okay, so those are two different things. On the first part of her trip, from Toronto to Sudbury, 110, and then from Sudbury to Sault Ste. Marie, 95 kilometers an hour. The entire trip without stopping, okay, was 6.5 hours, and the total distance traveled was 670 kilometers. Find the distance to each city. Okay, so we need to define what our variables are here. They want to know the distances to each city. So from Toronto to Sudbury, okay, that's one of the distances we have to find. And the other one is from Sudbury to Sault Ste. Marie. Okay, so these are the two things we're looking for. So I'm going to give them variables. So for Toronto to Sudbury, we're going to say let X represent that. Okay, from Sudbury to Sault Ste. Marie, let Y represent that. Okay, so in this question, they want us to find the distances. Okay, and we have our let X and our let Y. And really the goal would be to find the distances. But the way this question is set up, because we know we're traveling 6.5 hours, when I say let X and let Y, I'm going to actually do in terms of time. Okay, so what I mean by that is X is the amount of time, okay, the amount of time from Toronto to Sudbury we spent traveling, and Y is the amount of time from Sudbury to Sault Ste. Marie. So if I take all the time of the first trip and add it to all the time of the second trip, that will be 6.5 hours. Okay, and it'll be easier to set it up this way than as the distances. So we know X plus Y is equal to our 6.5 hours. Okay, because these are time, they lend themselves very well to our second equation. Actually, let's call this equation 1. Okay. Our second equation is we know that we're traveling 110 kilometers an hour. Okay. So we're going this speed assuming we're going an hour, but we don't know how long we're traveling for. And same with 95 kilometers an hour. And we know that if we take those two times, so say I travel for an hour at this, an hour at that. Okay. If I take those two times, that'll tell me a total distance traveled. For instance, 1 hour of this trip, I would have traveled 110 kilometers. And in another hour, I would have traveled another 95. Together, it would be about 205 kilometers. Okay? But we know actually the total trip is 670. So what that means is this is going to equal to 670. And we know that our 110 needs to be multiplied by our x being how long we travel at that speed, and our 95 needs to be multiplied by our y, because that's how long we traveled at that speed. Okay, and this gives us our second equation. Okay, so now that we've built the two equations, remember, when we solve x and we solve y, it's actually not what they're asking us. That's only going to give us the times. And then from the times, we'll be able to figure out what the actual distances to each city were. So there's a whole extra part, so I'll kind of put an addition, that we'll have to do after we find this linear system. Okay. So this part here we're kind of used to using. They're relatively big numbers here. So we could do elimination or substitution. Do you have a preference? Which one you'd like to see?
No.
No? Okay, I'm going to do substitution just because it'll be really easy to isolate a variable in our first equation. Okay, so in equation 1, I'm going to rearrange it so it's x is equal to 6.5 minus y. Does that make sense to you?
Mm-hmm.
Okay, so then I'm going to take equation 2, right, and 110 times 6.5 minus y. So what we did there is we just replaced x with our 6.5 minus y, okay, plus 95 y is equal to 670. From here I'll write in black, okay, just so we saw some substitutions. So we'll have to use distributive property here. And when we distribute this value, bring out our calculator here, 6.5 times 110, okay, 715. So that's 715, the first distribution. And the other one becomes negative 110y plus 95y is equal to 670. We want to keep all of our variables on one side, our like terms, right? So I'm going to leave these two variables on the left, and we'll take our 715, move to the other side. When we move something to the other side, do you know what operation it will become, this positive 715?
A negative.
That's right. So we have 110y plus 95y is equal to 670 minus 715. Okay. So let's collect our like terms. I'm going to kind of go through this here. Negative 110y plus 95y will actually give us negative 15. All right? Yeah. Negative 15y. Okay. And if you have a calculator, you can double check it. And 670 minus 715 will give us negative 45. Okay. I then have to isolate for y, so I divide both sides by 15, or I bring the 15 over and divide by, sorry, not just 15, negative 15. And that will mean y is equal to 3. Okay. So we know that the time spent traveling from Sudbury to Sault Ste. Marie was 3 hours. We got the first part of this trip. Okay. What's good about this now is we can take equation 1, which was relatively simple. Okay. And we can take any version of it. In fact, we'll take this version. Actually, no, we'll take the original. X plus y is 6.5. So back to equation 1, x plus y equals 6.5. Well, we know y is 3, so we'll substitute 3 in for y. X plus 3 equals 6.5 becomes x equals 6.5 minus 3. X is equal to 3.5 hours. Okay. So many people at this point would go, okay, we're finished. But remember, we talked about this. They're actually looking for the distances. So I have to do a whole extra amount of work here. I actually have to take my 3.5 hours for x, my 3 hours, and kind of plug them into sections of equation 2. This section, 110 times x, will tell us our distance traveled for Toronto to Sudbury. And this section here, 95 times y, or times 3, will tell us our distance traveled from Sudbury to Sault Ste. Marie. So I'll do that on the right. I'm doing a little different colors here. We'll do the first part in green. So that's 110 times 3.5 equals, and this will be our distance traveled. Near our calculator. Oh, it's over here. 110 times 3.5, 385. Okay, so 385 kilometers from Toronto to Sudbury. Okay, I'll do the other part, kind of purple here. 95 times 3, that's going to give us 285, I think. 285 kilometers from Sudbury to Sault Ste. Marie. And to double check we got the right answer, I'll just add those two together. When we add the two together, what should we get? Do you know?
670?
Yeah, 385 plus 285. 670, perfect. So we finally figured it out. So not only do we have to solve this linear system, we just have to put in some extra work because they weren't looking exactly for what we had to set our variables equal to. Okay?